All right, this last question, they were given a differential equation here. They want us to find the second derivative of this. So in order to find that second derivative, it looks like here we're going to have to take the derivative of both sides of this equation here. So derivative of the left side would just be our second derivative here. Derivative of the right side, so derivative of y to the fourth would be just using our power rule here, 4y cubed. But it's a y, so you got to think just like we did with implicit differentiation. You got to include dy dt here. Derivative of the second one is, again, just using our power rule, so minus 18y squared. But again, this is a y one, so you got to include dy dt. Okay, so one thing I notice here, both of these have a derivative, and so one thing we could do here is factor that out. So if we factored out our first derivative, we get this. And sometimes that's all right, but other times on these problems, what they're going to say is write your answer so that you don't include any derivatives other than that first one. So what you got to do then is, if they want the second derivative to not include the first derivative, even though it's right here, you want to make a substitution. Now we know that dy dt is equal to what we have here, so if we substitute that back in, then our second derivative only depends on y, it doesn't depend on the first derivative. So if we make that substitution, now our second derivative becomes this. And now we only have y as part of this second derivative. So that would be the second derivative now without that. And of course, if it's like a AP type question, like a multiple choice, and you got to match it up, then go through and simplify this out by distributing, doing some FOIL here. We get that. It's 18y to 6. That last term would be positive. Let's see, 108. Y to the fifth. Then we got a couple like terms there we could combine together. So simplified, we'd get this. So that would be the simplified second derivative of this one. So the key when doing these, if your second derivative includes the first derivative, good chance you're going to have to substitute that in using the given differential equation that you started with.